So in this video, we'll be talking about Spark memory management, how exactly Spark distributes its memory. It is very important topic whenever you go for any sort of data engineering interviews for any sort of levels. Okay, so it is very important. So we'll be talking about in detail from the scratch. So let's go on the screen. And who am I to guide you? Hi, my name is Anurag Shora. So I am a senior data engineer working at a remote company named as Contact, and I'm a DataX professional certified data engineer, and I have been also guiding many people through my bootcamps and all. So definitely I am a good person to guide you with the things. I have guided more than focused about 400 people, and apart from that, in the data enthusiast, I have guided more than 3,200 people. So let's talk about the things. Let's see. So as you can see on the screen here, and this is the main memory here. As you can see, this is how the main architecture looks like. You can just take a screenshot, or I'll basically just take a screenshot, and or you can just save this video. That's how it works. Let's break it down block by block, what exactly all the things are meaning and how the things will go. So we'll be talking about all those sort of things also. Let me start with my annotator. So the toolbar, my pen, I'll take a red pen, and let's start with the thing. So basically, whenever we talk about an executor, it's Spark memory, executor memory. So basically, whenever we talk about, there are three sort of memories. Okay, in Apache Spark, there are three major memories. That is first one we talk about. Whenever we talk about Spark memory, executor memory management, we talk about unified memory, we talk about off-heap memory. These are the major terms in interviews. Also, people will try to confuse you on those things, like what is unified memory, what is executor memory, what is off-heap memory, what is on-heap memory. So we'll be trying to break down all those sort of things, so it will be easier for you to understand everything. Okay, so let's go down, and here we can see, as we can see here, that this is the main, like, executor memory, executor container we talk about. Okay, what is an executor container? So whenever we say that about 10 GBs of memory is given, about 12 GBs of memory is given, so suppose we are giving about 10 GBs of memory. So this as a whole will say it as a 10 GB of memory as a whole. The executor container, the on heap will be 10 GBs of memory. There are two parts. There is a on heap memory, there is a off heap memory. Okay, the off heap memory will be disabled, as it is written also. It will be disabled by default. It is very important to understand this point. That is, it is disabled by default. If you have to enable it, you have to give a command to enable it, and you have to give the size also if you want to enable it. So it is not preferred also, because it is slower memory also as compared to the on heap memory. So basically we don't prefer that. If there is a requirement, we will better increase the number of memory, the size of memory. Okay, so that is also one thing. So let's talk about this thing, that is basically what is the Spark executor container. So in the Spark executor container, as you can see, there will be different sort of memories: on-heap memory and off-heap memory and overhead memory. These are the three major memories that we'll be talking about. In the on-heap memory, that is a main function. That is a main function where Spark will do all those sort of different executions, allotment of the memory, deallocations of the memory, execution of the things, storing your different sort of broadcast joins, broadcast variables, RDDs, your data frames. Everything will be done here, and in the all those sort of things. Okay, let's break it down in much more granular aspect. So first one, that is the executor memory. Executor memory, execution memory. Whenever we talk about this is the main priority memory. Whenever a Spark is getting a Spark job is, or a Spark compute is getting defined, or whether you define a job, whenever a program is coming and it is hitting on that, whatever kind of things are there, the main priority will be this memory. This is the priority memory, because every time, because this is doing the major work, the major heavy lifting will be done on this memory. That is all sort of joins, shuffles, sorting, group by, any type of main executions will be done on this particular memory. That is called as execution memory, or executor memory, or the main memory also we call it as. In the on heap memory, that is the execution memory. Okay, we'll be talking about the segregation also, how everything is getting segregated, what are the major aspect I have written in the here also, but better we will be trying to cover it off also. Okay, don't need to worry about that thing. What is the meaning of this one? We'll be talking about that also. Why I have given a arrow here, a double headed arrow क्यों दिया है वो भी समझेंगे. ठीक है, don't need to worry about that thing. Next comes the storage memory. Storage memory is a memory where basically all the type of whatever you are declaring, the data frames, the RDDs, because whenever you define a Spark data frame, the main fundamental fundamental data type of a Spark memory will be what? Will be your RDDs. ठीक है, RDDs are the main things of this one. ठीक है, so try to understand that also. So we will open it again. I think so some problems. ठीक है, some clicks happens ना, so this is how the problems will happen. We'll scroll it off and we'll try to understand this. ठीक है, so here basically whenever we talk about any sort of storages means if you are defining any sort of means any sort of memory or any sort of things. ठीक है, whenever you will define any sort of RDDs means resilient data set, the fundamental unit of your data, like data frames are RDDs. Spark fundamental data structure of storing a data frame is RDD, resilient data set. It is a data structure that is immutable also, so we'll not go that further. We'll try to understand this. So we store RDDs, we store data frames, any caching if you are doing of any data frame, that we'll do, any sort of broadcast variables that you are sending, broadcast joins you are sharing. So all those sort of things will be stored in your storage memory. Very, very important to understand. Okay, after this, whenever we talk about that is the user memory. User memory is something that is user defined data structures. If you have created some like say objects, classes, all those sort of things that will be stored in your user memory, or variables if you are defining any sort of things, that all things will be stored. Any sort of objects if you are storing, that all sort of things will be going in this particular memory. Apart from this, basically this memory is very, very important. That is reserved memory. Reserved memory by default is 300 MBs. It can be definitely greater than this. You can also increase that type of memory, and it will be by default. These all sizes are by default only. Whether by default for a broadcast join also 50 MBs are there, or I think not 50, I think 10 MBs are there. 10 MB you can broadcast a data frame across all the executors by default, but definitely you can increase it also. By default it is 10, but it can increase also. Similarly, by default it is 300, it can be increased also. Okay, so it depends on how much size you are giving it. By default it is 300. No one will like majorly whenever as I am working as a data engineer, I have seen that no one will do these sort of things and all कि हाँ फिर से इसको optimize कर देते हैं, फिर से इसको बढ़ा देते हैं. ठीक है, those sort of things people will not do. That is also one sort of thing. Let's talk about these two things. What is off memory and what is overhead memory? Overhead memory is something like suppose 10 MB, like say 10 GB of file is given. ठीक है, so it will 10 GB of your storage or your RAM is given, okay, to this particular executor. Okay, so basically whenever we talk about overhead memory is the extra memory. Overhead means extra. It is extra. It is not included into main memory of 10 GB, but how much it will be given, as the formula is written, max of 384 MBs and 10% of your executor memory. 10% of your executor memory, और इसका 10% of executor memory होगा about 1 GB. ठीक है, if 10 GB of this is given, about 1 GB will be 10% of this particular memory. ठीक है, 10% means 1 GB and 384 का मैक्सिमम कितना होगा? इट विल बी 1 GB ओनली, तो ओवरहेड मेमोरी विल बी ऑफ 1 GB. ठीक है, दिस इज हाउ दीज ऑल मैथ्स आर इंपॉर्टेंट एंड ट्राई टू मेमोराइज दिस. जस्ट मेमोराइज इट. व्हाई इट इज कॉल्ड एज यूनिफाइड मेमोरी एंड व्हाट इज द मीनिंग ऑफ दिस एरो? यूनिफाइड मेमोरी बिफोर वर्जन I think so 1.2 or something like that. Before the version this basically it was 1.6. It is not 1.2, it is 1.6. Before version 1.6 it was fixed. Like executor memory, if it is given like about say 5 GB is allocated and 5 GB is allocated to this person, so it will be like, it will be, if it is empty also, you will be not able to give this memory this one. But after 1.6 Spark version, it was unified, means it can be unified. This slider, there is a slider, it can increase or decrease. ठीक है, it can increase if the execution memory it is required more, it will take that memory from the storage memory. So that was defined after 1.6 Spark version. Try to remember this, Spark version 1.6. ठीक है, so after that basically we talk about, let's talk about the maths now. ठीक है, what is the maths behind these things? Whenever we define, see suppose whenever we are taking about 10 GB, suppose I am taking about 10 GB of, for very easier calculation I am taking 10 GB of the executor memory. ठीक है, so what is a Spark executor memory? Spark executor combines the execution memory and the storage memory. If we combine these two memory together, so this will be called as the Spark executor memory, and that will be 10 GB in total. But whenever we talk about Spark executor memory into 6, that is called as this unified memory will be 6 GBs. Okay, 6 GBs it will be. Then we talk about, and 6 GBs will be divided into 3 GB and 3 GB. 3 GBs will be given to these two people. Okay, 3 GBs and 3 GBs will be given to these two people. That is very important to understand. Half will be given. 0.5 will be given to this one, that is 3 GB and 3 GB. And total these two combined will be 6 GBs. Okay, try to understand. The unified memory will be 6 GBs. Rest, how much is left? Now 4 GBs are left. So that will be basically, now this will be 4 GBs. The 4 GBs will be combination of reserved memory and the user memory. That means if we combine, that is 4000 minus 300, that is a reserved memory, that we talk about 37, about 3.7 GBs will be given to the user memory to store your unified user defined data structures, variable objects, those sort of things. You will be storing it there. Okay, apart from that, if we talk about any sort of, like if you want to increase, and this will be, always remember, this is the priority memory. Execution memory will be your priority memory. Okay, this is how the calculations has to be done, and this is how you need to understand the things. And if we talk about basically what happens, whatever if we talk about these things, okay, let's understand this also. Before, if we are talking about after 1.6, okay, after Spark version 1.6, because before that this was fixed bit. If it is given 3 GBs here and it is given 3 GBs here, so it will be fixed. But after 3.6, it was a slider. This arrow means it is a slider here. And if the executor, I have taken different cases for this, because to understand it, if the executor memory is full and storage memory is idle, okay, so you can take the memory from the storage memory and take and utilize it for the execution memory. The execution can be done from taking the memory from the storage memory. Try to understand that, because this is the priority memory. Execution is the priority task of any Spark job. Okay, second thing is basically to understand about the case 2. Case 2 is something that is basically, whenever we talk about executor memory in idle, whenever executor memory is idle and storage memory is full, so definitely it can slide up and take the memory from the executor. If executor memory is idle, try to understand that if it is idle, then only the storage memory can utilize it. And how it utilizes, there is an algorithm called as LRU, least recently used algorithm. Whenever we talk about any type of caches, this is the major eviction algorithm we talk about, that is LRU, least recently used. This is the algorithm that it uses to like differentiate or use about, or to free up the thing, so that it can be utilized by next one. So whenever we talk about third case is basically when storage memory is also full and executor memory is also full and execution memory is required more. So as this is our priority memory, this execution memory is our priority memory, this is our priority memory, right? So it will try to occupy the storage memory, because it will try to free up the memory, storage memory, by using LRU algorithm, that is least recently used algorithm, and it will try to free up the things. Free up karega tabhi to it will be used by the execution memory. That is the main use case, because it is a priority memory, so it will utilize the storage memory and try to free up the whatever caches you have done, whatever broadcast join you have done, whatever broadcast variables that has been used, that last जो सबसे least recently used है उसको it will free up the things. That is how it works basically. ठीक है. Apart from that, the fourth one basically when executor memory is full and storage memory is full and more sort of storage memory is required. ठीक है. So what will happen? It will not free up the execution memory, because this is the priority memory. Always remember, this is the priority memory. It will not free up the executor memory. Always the storage memory will be freed up. And how? By using LRU, least recently used algorithm. ठीक है. So this was all about the diagram or the architecture of the Spark memory management. Very, very important. Whenever you go for any core data engineering roles, it will be used and it will be asked, whether you go for a Geo interview, PwC interview, Deloitte interview, there if a good package is given, definitely these sort of questions will be asked, because this is how you will understand whenever in the live environment compute is getting utilized or full or memory is getting skewed, where you need to improve the things and how you need to manage the things and how the things are getting distributed. This was all about the video. video. Thank you so much for watching it. Any sort of, you want to learn these kind of concepts from the scratch, from the zero, with all the backgrounds and all, and any sort of doubts, you can ask me definitely. So you can get into our DataX Bootcamp. That is, the link is in the description. Directly you can take that, and we have a coupon code also given for, especially for our YouTube family. Definitely utilize it and you can use it. Thank you so much. And the full bootcamp, it is in English, and it is self-paced from any sort of country you are, and globally, if you are from any sort of background, you can definitely utilize it. Start it from the scratch and you can become an AI ready data engineer from zero. So definitely you can utilize it. Thank you so much for watching this video. Jai Hind, Vande Mataram. Bye bye.